Now in this lecture, we continue processor examples. In the last lecture, we discussed ARM processor. Now here, Motorola 68,000 interrupt structure we are going to discuss. Now this is the register structure of 68,000. If you see 0 to 31 means 38-bit registers, and few data registers are there, few address registers are there, stack pointer, program counter, and condition code register is nothing but a status register. Now these are the registers inside the 68,000 register, 68,000 processor. Now total here it is having 8 interrupt levels. Now this is the status registers, the same status register. Now here once again I am showing 0 to 15 bits. Now 8 to 10, 8, 9, 10 bits. These bits are used to give the priority to the, indicate the priority of the interrupt. Now 0, level 0 is having all bits 0 means what? It is level 0 is having lowest priority. If all bits are 1 means it is a level 7. This is having the highest priority. Whenever the level 7 interrupt is occurred, then that is a edge trigger and a non-maskable trigger. Whatever the processor is executing, when the level 7 trigger is occurred, then at the time processor is supposed to execute this interrupt. Now again here it is having the trace and the supervisor mode. If the trace bit is equal to 1, we can execute the program in a trace mode, means a bit by line execution can be done. If S bit is equal to 1, then we can operate the system in supervisor mode. If S bit is equal to 0, we can operate this in user mode. And here the conditional flags, carry flag, V is a overflow flag, Z 0 flag, and negative flag. X is not defined, undefined. So these are the conditional flag. Now what happens if the interrupt occurs in the Motorola 68,000? Then whenever the interrupt occurs, automatically the program counter value and status register values are stored onto the stack. Now in the case of ARM, we have seen that those values are stored onto the specific registers within the processor. Now, but coming to the Motorola 68, now again program counter value and status registers values are moved onto the stack, and after completing the execution, then again it will restore the status register content and the program counter value onto the specific registers value by using the pop instruction. Now this can be moved onto the stack by using the push, and again the addresses are again copied back to the PC and CPS by using the pop instruction. That is which internally it happens. Now, in the case of 68,000, the RET return instruction, it will be write as RTE, written from interrupt instruction. Now, in general, in the interrupt concept, we have seen that RET, written. But here, I written or written. Here it is RTE, interrupt from, written from interrupt instruction. Now, this is what happens inside the microprocessor. Now, it is 68,000 processor uses the vector interrupts. Whenever an interrupt is occurred, that is received by the processor, and after getting the acknowledgement, then the processor will send the vector code on the data bus. Now, total it is having 256 interrupt vectors. And here auto vector facility is also provided in 68,000 microprocessor. Now, the next one is Pentium interrupt structure. Now, Intel IA32 uh, uh, processor we are discussing here. Now, if we see the register structure, now it is having these A, B, C, D are the data register. E is extended. Wherever you see all E, it is indicated. E is extended. And these are the data register. These are the pointer register, index register, and these are the segment register. Total memory is divided into segments, and in a code segment, code will be loaded. Stack segment is used for the stack purpose. Data segment is used to store the data. So complete memory is divided into blocks, and in that specific data is stored in data register, code is stored in the code registers, and stack register used for the stack purpose. Like that, and names are also given: CS, SS, DS, ES, extra segment. Like that, few names are also given. Here, one more register is IP register, instruction pointer. And next one is a flag register or status register. Now, if you see here, PC is not there, program counter is not there. But program counter is nothing but which holds the address of the next executable instruction. Here, CS along with IP both together used as a program counter. Now, these two together will work like a program counter. Here, there is no specific program counter name is there, but the job is that program counter job is done by using the CS and PC. By using these two register address, that offset address, by using this CS and IP address, we can find out the physical address of the memory. So now whenever the interrupt occurs, then what happens inside the processor, we will see. Before that, let me explain what are the different types of interrupts are there in the Pentium. Now here two types of instructions are there. One is a non-maskable interrupt. Whenever this is having the highest priority, whenever this interrupt is occurred, then processor must execute this ISR. Now the second one is maskable interrupt or simply INTR interrupt. Depending upon the priority, current program, whenever the processor is executing the current program, if interrupt is occurred, then it will check the priority. If it is a lowest priority, processor can neglect this interrupt. Otherwise, if the priority is a highest priority than the current executing program, then it will accept that interrupt. These are the maskable interrupt. Processor can mask or can neglect the interrupt also. And apart from these are the external, and apart from these, other exceptions are also there. When opcode is invalid, opcode is there, then division errors are there, like div by zero, and overflow occurs, and many others like trace and breakpoint interrupt also available. Now, whatever we have discussed in the interrupt concept, now all those types here you can see. Now this is a status register. Once again, we have taken the, now here you can see the conditional flag, total 32-bit register. In this, we are observing only 15 bits. Why? Because here we are discussing the interrupts. The remaining are for the conditional. Now here we can see the interrupts. IOPL is nothing but a input output privilege levels. Now 12, 13 bits, 2 bits we are using to give the privilege level. And IF is it is a interrupt enable flag, and TF is the trap flag. By making TF is equal to 1, we can enable the trap, and by making IF is equal to 1, we can enable the interrupt. Means what? Whenever IF is equal to 1, interrupt will be accepted by the microprocessor. Whenever TF is equal to 1, then we can execute the program instruction line by line. After every line, there is the exception will be occurred. Now in the Pentium, along with the main processor and one more, now here APIC controller is available. This is nothing but advanced programmable interrupt controller. Now all the IO devices are connected to this IC. This is one more IC. This IC is called as an interrupt controller. Now all the IO devices are connected to the, now if you take, this is the processor, this is the main processor, and this is the interrupt controller. And for this, all the IO devices are connected. Now IO device 1, 2, 3, 4, how many number of devices we are connecting to the processor? All we are not connecting directly to the processor, we are connecting to the APIC, advanced programmable interrupt controller. Now, whenever these devices are generating the interrupt, all the interrupt will be collected by this IC, the controller, and it will check the priorities, and which is having the highest priority, that priority will be that interrupt will be sent to the microprocessor, and after receiving it will send the acknowledgement. After taking the acknowledgement, again the interrupt controller will send the vector code to the microprocessor. Thereby, microprocessor knows the starting address of the ISR, and processor will execute that ISR. Now this is how the processor is handling the multiple interrupt. Now what happens when the interrupt occurs in the Intel? Now it will copy the status register, and it will copy the code segment value, and also it will copy the instruction pointer onto the stack. Now here also in the Intel Pentium, it is using the stack to copy the content. And if now this is a normal case, if any abnormal execution is occurred, then at the time it will copy the code also. It will copy the code onto the stack also. No, code is also copied. Now after that, what it will clear the interrupt enable flags, so that in between another interrupt should not be accepted, should not be generated, or if generated also, it should not be accepted by the processor. It will disable the interrupt. Now after completing, and after that it will by checking the vector code, it will go to the interrupt. Now in the memory, it is having one table for corresponding vector code. What is the starting address of the ISR will be mentioned. That table name is called IDT. IDT is nothing but interrupt descriptor table. From that, it will get the starting address of the ISR and it will execute the ISR. And after completing the execution of ISR, again it will enable the interrupt, and also it will load the CS and IP onto that particular register, and also copies the status register onto the status register value onto the status register. Now this is what happens inside the Pentium microprocessor.